operate and maintain detection and preventative measures. Welcome to this lesson on operating and maintaining detection and preventative measures. Security threats evolve constantly, making it essential for organizations to deploy and manage security tools that detect, prevent, and mitigate cyber risks. These tools include firewalls, intrusion detection and prevention systems, IDS, whitelisting and blacklisting, honeypots, and AI-based security solutions. By implementing and maintaining these security controls, organizations can reduce attack surfaces, detect threats faster, and prevent breaches. In this lesson, we will explore different detection and preventative measures and discuss best practices for their implementation. Let's get started. Cyber threats such as malware, phishing attacks, and unauthorized access attempts occur daily. Without proper detection and prevention mechanisms, organizations may suffer financial losses, data breaches, and reputational damage. Think of detection and prevention tools like a home security system. Motion sensors, security cameras, and alarms help detect intrusions, while door locks and reinforced windows prevent unauthorized entry. In cybersecurity, firewalls, IDS, IPS, and AI-driven analytics serve a similar purpose, detecting and stopping threats before they cause harm. For example, if an attacker attempts to exploit a vulnerability in a company's web application, a properly configured web application firewall, WAF, can block the attack before it reaches the server. Deploy a layered defense strategy combining multiple security tools. Regularly update and tune detection and prevention systems to handle emerging threats. Monitor security logs and alerts to quickly detect suspicious activities. Firewalls serve as the primary security barrier between an organization's network and external threats. They monitor and filter incoming and outgoing traffic based on predefined security rules. First, network firewalls control traffic at the perimeter, blocking unauthorized access attempts. Second, web application firewalls protect online applications from attacks like SQL injection and cross-site scripting, XSS. Third, next-generation firewalls, NGFWs, integrate advanced features such as deep packet inspection, DPI, and threat intelligence feeds. For example, an NGFW can detect an attempted ransomware attack by analyzing network traffic patterns and automatically blocking the malicious connection. Configure firewall rules to allow only necessary traffic. Use web application to protect online services. Regularly update firewall rules to adapt to new threats. Intrusion detection systems, IDS, and intrusion prevention systems, IPS, monitor network traffic for malicious activity and take action to stop potential threats. First, IDS passively monitors traffic and generates alerts when suspicious activity is detected. Second, IPS actively blocks threats in real time by enforcing security policies. Third, IDS-IPS can be signature-based, detecting known attack patterns, or anomaly-based, identifying unusual behavior that may indicate an attack. For example, an IPS can detect a brute force login attempt on a company's VPN and automatically block the attacker's IP address. Deploy both IDS and IPS to monitor and respond to threats. Use a combination of signature-based and anomaly-based detection methods. Regularly update detection rules to recognize new attack patterns. Whitelisting and blacklisting are techniques used to control which applications, users, and network connections are allowed or denied access to systems. First, application whitelisting ensures that only approved software can run on an organization's devices. Second, blacklisting blocks known malicious applications, IP addresses, and websites from accessing systems. Third, a combination of both techniques enhances security by limiting access to trusted resources while blocking known threats. For example, a company can whitelist only approved email domains to prevent employees from receiving phishing emails from unknown senders. Use application whitelisting to prevent unauthorized software execution. Maintain updated blacklists of known malicious domains and IPs. Combine whitelisting and blacklisting for a balanced security approach. Honeypots and honeynets are security mechanisms designed to lure cybercriminals into engaging with decoy systems, providing valuable insights into attack techniques. First, honeypots simulate vulnerable systems, attracting attackers who attempt to exploit them. Second, honeynets consist of multiple honeypots working together to monitor and analyze large-scale attack campaigns. Third, security teams use data from honeypots to improve threat detection and enhance defensive strategies. For example, an organization deploying a honeypot server may detect repeated login attempts from an unknown source, helping them identify and block potential attackers. Deploy honeypots in controlled environments to gather threat intelligence. Analyze honeypot data to identify emerging attack trends. Ensure honeypots do not expose real network vulnerabilities. Artificial intelligence, AI, and machine learning (ML) are revolutionizing cybersecurity by enabling automated threat detection, anomaly detection, and predictive analysis. First, AI-driven security tools analyze vast amounts of data to identify patterns and detect potential threats. Second, machine learning models adapt to new attack techniques, improving threat detection accuracy over time. Third, AI-based systems reduce false positives by distinguishing between legitimate and suspicious activities. For example, an AI-powered user and entity behavior analytics (UEBA) system can detect an employee accessing sensitive files at unusual hours and flag the behavior as a potential insider threat. Implement AI-driven security solutions to enhance detection capabilities. Continuously train machine learning models on new threat data. Use AI-based anomaly detection to identify insider threats. Now, let's summarize what we've learned about operating and maintaining detection and preventative measures. Firewalls serve as the first line of defense by filtering network traffic. IDS/IPS detect and block malicious activities in real time. Whitelisting and blacklisting control which applications and network connections are allowed. Honeypots and honeynets provide valuable threat intelligence by attracting attackers. AI-based security tools improve threat detection, reduce false positives, and predict cyber threats. By implementing these best practices, organizations can strengthen their defenses, detect cyber threats faster, and prevent security breaches. This concludes our module on operating and maintaining detection and preventative measures. Up next, implementing and supporting patch and vulnerability management. Stay secure.